We're going to switch now to doing experiments with real logic gates. What we're going to be using is a series of transistor logic, TTL. It's been around for 30 years or more. It's called the 7400 series. Now, in general, this is not a series that's used today, but enhancements of this series are still being used. For example, a 74 AC series. What I have here is a device called a logic monitor. Along the bottom are pins of these ICs. Now the ICs, as you see, are in a package that's called a DIP package. That stands for dual inline package. There are 7 pins on this side and 7 more pins on the other side for a total of 14. The device that's being tested is this. It's called a 7408. Basically what this is 4 AND gates in a package. Each AND gate has 2 inputs. So it's called a quadruple 2-input positive AND gate. Now the voltages are on pin 14, VCC. That's 5 volts. Pin 7 of most 7400 series is connected to ground. So there's 5 volts between VCC and ground, and that's what makes this circuit operate. So now let's look at what we actually have on the circuit. The connections to pins 1, 2, and 3, which is the first AND gate. Now if you remember from the truth table for an AND gate, if any input is a 0, the output is a 0. In this case we have both inputs 0, so the output should be 0. On the next gate, one input is a 1, but the other input is a 0. Once again, any 0 on an AND gate means the output is a 0. Only if both are 1 do you get a 1 output. And that's the situation that we have up here on pins 13 and 14. And so this pin, 11, should be a 1. So we should have a 0 on 3, a 0 on 6, and a 1 on 11. So let's take a look at that. As you can see, pin 1 and 2 are 0s, and so is pin 3. Let me turn on a little bit of light. Then, similarly, 4 is a 0, 5 is a 1, so 6 is still a 0. These are the 2 inputs to this one. But now let's look up here at the outputs. Now remember the one on the far left, that is VCC or 5 volts. We have a 1 on pin 13, a 1 on pin 12, and a 1 on pin 11. That, if you remember, is what we expected to find with a 1 on 13, a 1 on 12, we expect to find a 1 on 11. Now right now this third gate, or fourth gate I should say, is simply floating. Now this is not usually a good idea, especially if you have the output tied to some circuit. In other words, you shouldn't let the inputs float. It's not that it's going to burn up, it's just that noise can get in here and cause this gate to exhibit strange behavior. So what we are illustrating here is that when an AND gate has any 0 on its input, whether it's 0, 0 or 0, 1, the output is 0. Only if it has a 1 and a 1 on its inputs will you get a 1 out. Now, if this were a 10-input gate, you'd need 10 1s. If this were a 5-input gate, you'd need 5 1s, and so on. So let's take a look now at a 3-input gate and see how that works. I've now wired up a 3-input AND gate. It's called a 7411. And you notice in the upper corner there it says triple 3-input positive AND gate. The inputs to this are a little different. VCC, or 5 volts, is still connected to 14. Ground is still connected to 7. But you notice that instead of using pins 1, 2, and 3 for this first gate, it uses pins 1, 2, 13, and 12. This gate is wired up with 1s on pins 3, 4, and 5. So pin 6 should be a 1. All 3 inputs of the AND gate are 1s. So let's look at that. Over here you see pins 1 and 2 are 0s. Pins 3, 4, and 5 are 1s. And pin 6, which is the output, is a 1. However, let's look at something that I mentioned earlier, and that has to do with floating inputs. Now, what I'm going to do is zero in a little bit on this logic monitor, and you will notice that pin 13 shows a 0. Pins 1 and 2 show a 0. Well, if you look at the AND gate over here, you'll see that if 13, which is up here, and 1 and 2 are all zeros, the output should be a 0. And it is. But the reason it's a 0 is because I have pulled one of those inputs low. 2 of them are floating, and 1 is pulled to ground. I'm going to remove the ground on pin 1 so that pins 1, 2, and 13 are floating. Watch what happens to the output. You see, it went high. This is the problem with floating inputs in TTL. Floating inputs usually float to a 1, but it's not a good idea to depend on a floating input being a 1. Like I said earlier, it can be noisy. So you should have learned 2 things from this. The first is how the 7400 series works, how you connect power and ground to it. The second thing is the way you use the 7400 series is subject to a series of design rules. They're not very complicated, but one of the more important design rules is don't float the inputs. If you're not going to use them, tie them to ground or tie them to VCC. Now there are lots of other rules about loading and other things that have to do with when you start using a lot of these gates in a circuit and so on. We're not going to talk about those at this point. Instead, we just want to make the point that with an AND gate, whether it has 3 inputs or it only has 2 inputs, as in the 7408, all of the inputs have to be a 1 for the output to be a 1. So once again, I hope you have enjoyed this part, and I hope that you'll stay tuned for some future parts in which we try to put together some interesting logic circuits.